This is Scholle Physics Combination Circuits Part 2. In this brief segment, you're going to learn how to calculate the current through each individual branch in a parallel section of the circuit. So here we have a very similar circuit to Part 1. Actually, it's the same circuit, 2 ohms, 5 ohms, and 10 ohms attached to 15-volt battery in a combination. What I have added here are a couple of current meters or ammeters in the branch section. So here we see the simulation giving us some answers here, but how would you determine that on your own? So here I'm going to recreate this circuit. Try to turn that off. All right. So there's 2 ohms. Give a little bit more room here. 5 ohms. And please feel free to sketch this on your own. I think that would be good as far from a notes perspective. Okay, 5 ohms and 10 ohms. If you work this through with me. Now you might recall this is 3.33 ohms, but I'll solve that quickly. Just if you're watching this video without watching the others, we had a 15-volt battery here as well. So the first thing, before we figure out, if we label this resistor 1 and resistor 2, before we figure out current through resistor 1 and the current through resistor 2, we need to determine what the current from the battery is. So if we take all these resistors and find the equivalent resistance, how much current would then be flowing through the battery? Sometimes I'll call that the total current. It's the sum of the I1 and I2 currents when they come back together and split apart. So you'll see here I will go through this resistor and split up into those. So in this video, you're going to see how to find the potential difference and the current through all the resistors. I can actually make a table up. I can find the circuit, resistor 1, resistor 2, and I'll go ahead and label this one resistor 3. All right. So we're going to find the circuits V, I, and R values. Just make a little table here to keep all the responses together. Now we do know some of the values. Resistor 3 is 2 ohms, resistor 1 is 5, and resistor 2 is 10 ohms. The circuit's applied electromotive force or voltage is 15 volts from the battery. Put V over here, amperes and ohms. Okay, so there we go. That's what we know. And all the while, let's keep in mind our best friend, V equals IR, Ohm's law. If we know 2 of these pieces, we can figure out the third. If we know I and R, we can multiply them together to find V. If we know V and R, we can divide V divided by R to get I. And likewise, divide V divided by I to get R. So if we know 2 of the pieces, we've got the third. So you're going to see me as I'm filling out this table. If I get 2 of the pieces, I'll say, okay, the third one's easy to find now. So, and I might skip ahead and come back to it in the end. So if we find 2 of these pieces, we're good. All right, so the first thing, I want to look at the circuit, find the I. What's the I through the circuit, and what's the equivalent resistance there? Now, do this as quickly as possible. First, we're going to look at this as 2 sections. There's a 2 ohms in series with this parallel segment. So we're going to find the parallel segment's resistance first. 1 over 5 plus 1 over 10. That's how you find the equivalent resistance for parallel resistors. They are not in parallel to 2 ohm resistors, so we're only focusing on the 5 and 10. That gives us 2/10 plus 1/10 is 3/10. So RP over 1 is going to be 10 over 3, which is 3.33 ohms. All right? So that is just the resistance of this segment. I encourage you to write it in there. You're going to need it. We're going to need it here in a second. So now we've got 3.33 ohms in series with 2 ohms. So the equivalent resistance of the entire circuit is 2 plus 3.33, which is 5.33 ohms. And I'm going to write that right up here, 5.33 ohms. All right. We take 15 divided by 5.33, and that gives us the current, V equals IR. So 15 volts divided by the R value of 5.33, and that will be 2.81 amperes. All right, I can also check. There's my 2.81 amperes is the current through the battery. Excellent. All right, next step. Well, how about a next goal? Our next goal is to try to figure out the current and the potential difference across each resistor. So first, what about R3? All right, this current that comes out of the 15-volt battery will also flow through that 2 ohm resistor. So without having to calculate anything, the charges that flow out of the battery are equal to the charge that are the same charges that will flow through the 2 ohm resistor. So this 2.81 amperes is also the flow through resistor 3. 2.81 goes right there in my poorly constructed chart. Now I've got 2.81 and 2. That's an I and an R. If I multiply them together, I've got the V. So 2.81 times 2 would be 5.62 volts. All right. So 1.8 or 2.8 plus 2.8 is 5.6. So that's where I did that in my head there. It's good stuff. So next, what about these two? All right. So I don't have the V across them, and I don't have the I through them. So what do? The one thing I do have is the R, the resistance value for both of them. So you remember when we found the equivalent resistance of both of them, what we're doing, what we're trying to imagine them as, is a single resistor. We're trying to imagine them 5 and 10 as a single 3.33 ohm resistor. So what we just did was we found that the 2.81 amperes flows into 2 ohms. And that gave us 2.81 flowed into that 2 ohms, and that gave us the V, the potential difference across that resistor. So can't we do the same thing with our 3.33 ohm combination? Can we find the V across both of those resistors? Yes. So what we're going to do is take V equals IR in this situation, plugging in the 2.81 ohms that flows into both those resistors together. So 2.81 flows into 3.33 ohms of resistance. Now I'm not good enough to do that one in my head, so I got my calculator off here to the side. I'm doing 2.81 times 3.33. Of course that's a repeating value, but I'm getting 9.36 volts. Okay, so what this turns out to be is both these resistors have the same potential difference across them, 9.36. All right, now here's an interesting point. We got 9.36 is the potential difference across them. They're acting like a single resistor. So if we look at this, 9.36 together plus 5.62, guess what that adds up to be? 15. So if this was the only thing left that you had to do, what you could have done, if we didn't have any other resistors in the circuit, you could have taken that 15 and subtracted out the potential differences from all the other resistors. Now, if you look at this, you do need to consider these as one resistor, so be careful when you're doing that. You only subtract them once if it's a parallel resistor, okay? But what that does for us now is we've only got one unknown, the I value. So we take a V divided by R, and that will give us I. So V for R1, so V equals I1 R1 is what I'm plugging in here. And the V across could do a V1, that's fine, is 9.36 equals I1 times R1, which is 5 ohms. So if I divide by 5, I should get the current there. All right, so 9.36 divided by 5 is about 1.87. Now, if you look at this, will 1.87 also be the current through the 10 ohm resistor? Will it be greater? Will it be lesser? If you're thinking lesser, that's correct. I hope you weren't thinking greater, but if you were, that's fine. I would just ask you to guess. But think of it this way, there's more resistance in this part of the circuit. Will more electrons go through 5 ohms or will they try to go through 10 ohms? Since there's more resistance down here, then more electrons every second can pass through the 5 ohm resistor. They're going to be moving faster up here where there's less resistance, moving slower where there's greater resistance. So since these two are very comparable, 5 is half of 10, that means 10 will have half the current of 5. So you could just divide this in half, but what I'm going to do anyway is still take that V equals IR, but we're going to do this for that second resistor. 9.36 is the voltage across the potential difference across the second resistor. We're going to divide it by 10 because V equals I times R. When we divide that by 10, that one's easy to calculate. 9.36 divided by 10 is 0.936. I'm just going to say 0.94 amperes. It's always good to practice those units. 0.94. And look at that. If we take 1.87 plus 0.94, that equals 2.81. How's that supposed to be important? Well, remember, 2.81 is the current flowing out of the battery. It's the current flowing in the 2 ohm resistor. And so 2.81 should be the sum of I1 plus I2. Okay, and that brings us back to the battery. So that current will split up, and then it will recombine in the same amount and pass through the battery. So there we have it. We filled out the box, got all the components there. I1 is 1.87 amps, I2 is 0.94. Maybe that might be a little bit more visible for you. Right? 2.81 equals the sum of those two. That's where I find the current. This tends to be a little overbearing at first, but once you practice them and take them one step at a time, what we're doing is taking the V equals IR for the whole thing and then V equals IR for each little segment, one at a time. And once you do that, take a deep breath. If you get stuck, don't stop. Just keep going. And I hope this is helpful. And go ahead and practice some right away so it doesn't run away from you before you get that practicing. All right. Thanks for watching.